Hey you guys, today we're going to pick up a couple more properties of logarithms. So I'm calling this property of logs part B. Alright, the first thing we're going to talk about is the power rule. And what the power rule says is if you take the log base b of m to the p, what you can do with that exponent is move it out in front of the logarithm. Okay? So that's what we did here. And that's basically it. So let's put it to use and see how it works, okay? All right, let's look at the first one. We have the log base 5 of 7 squared. Well, what can I do with that square? According to the power rule, I can move it out in front of my logarithm. So that would be equal to 2 times the log base 5 of 7. Okay? All right, let's look at the next one. We have the log of the square root of x. Remember, the square root is the same thing as the 1/2 power. All right, and what we can do with that is move that exponent out front, and that'll be equal to 1/2 the log of x. All right, let's look at number 3. We have the natural log of x squared. Remember, natural log is a log with the base of e. I'm going to move that exponent out front, and that would be 2 times the natural log of x. All right, and then for number 4, you have the natural log of the cube root of x. Remember, the cube root is the same thing as the 1/3 power. I can take that exponent and move it out front, and I get 1/3 the natural log of x. Where the power rule is especially useful is when we have our variable in our exponent, and I need to get the variable somewhere where I can work with it, but that'll be in the future. All right, let's look at the next rule. All right, this is called the change of base property. And what it says is if you have the log base b of m, and maybe that's something I don't know, like log base 3 of 100. There's nothing I can raise 3 to get 100. So if I want to evaluate this, what we can do is we can change that to a log with a different base of this number divided by the log with that same base that you used in the numerator of the base from the original logarithm. And I'm always just going to use base 10, and I suggest you always use base 10 because it's the easiest thing to do. So let's see this in action. We've got the log base 4 of 12. Again, there's nothing I can raise 4 to and get 12, so I wouldn't be able to just evaluate this with my noggin. So I can change that to the log base 10 of 12 divided by the log base 10 of 4, and you're going to put this in your calculator. I'm actually going to change that to approximate. All right, so we have the log of 12 divided by the log of 4. And I'm going to go 3 decimal places, so the 2 will look at the 4 and stay the same. So that would be approximately 1.792. All right, let's do another one. We have the log base 13 of 48. So what we can change that to is the log base 10 of 48 divided by the log base 10 of 13. Get out my handy dandy calculator. And let's do the log of 48 divided by the log of 13. All right, we have a 9 in the 3rd decimal place. It looks at the 2, it's going to stay the same, so that'd be approximately 1.509. All right, let's do another one. We have the log base 5 of 13, and I can't use my brain to do that, so I'm going to change it to the log base 10 of 13 divided by the log base 10 of 5. I'm going to put that in my calculator. All right, and we have a log of 13 divided by the log of 5. All right, this time the 3 is going to look at that 6 and it'll actually round up. So that would be 1.594. Easy breezy, lemon squeezy. All right, so just to reiterate, the 2 rules we talked about today are properties. The first is the power rule. When you take the log of something being raised to a power, you can take that exponent and move it out in front of your logarithmic expression. And then for the change of base property, when you have a logarithm that you can't readily evaluate, what you can do is use a different base, and I always suggest base 10, and do the log of this divided by the log of the original base. All right, thank you so much. I hope you have a great rest of the day.